Hi everyone, so hope my screen is visible. Hello, hello. Oh, sure, awesome. Um, just we'll wait for other guys to join in, and we'll start. So yeah, just do tell me in case you're not able to see the screen. Yeah, awesome. Is the slide desk visible right now? Awesome. 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 Thank you, Shashi. So, hi everyone. So, as Shashi mentioned, one of our platform engineers working in my company called Sapient, and I'm working in a for a client called Nationwide. So basically, it's a financial organization where they are running their apps on Kubernetes. And as per as Kubernetes, so I'm part of their platform team, and I'm basically involved in the day-to-day setup of the platform. And I'm highly involved in their monitoring and observability team. So I'm actually one of leading their Elasticsearch team. So kind of that's my day-to-day work. So moving to what we're going to discuss today, here is a monitoring and observability in cloud native. So a very level. Sorry, hello. Mm, yeah. So yeah. Okay. So starting with the deck. So what we're going to discuss today is how monitoring and observability is done in cloud native. What's the basic difference between them and what they actually are, and why do we need them? And one of the technologies we'll see in this deck is Elasticstack. We'll see how Elasticstack enables us to do observability in the cloud platform. Also, followed by that, we'll be having a quick demo, and after that, we'll have some quick questions and Q&As that how we can proceed towards the observability side. So starting forward is the let's quickly go through the agenda. So the few topics that we'll be discussing in the agenda is what's the need for monitoring and observability, what is actually observability and how it is different from monitoring. We'll be again be talking about the three pillars of modern observability, and then we'll be seeing one of the technologies called Elasticstack. By Elasticsearch, we'll give a little bit introduction to Elasticsearch, and then be followed by a demo, and followed by the what are the steps that you can do to start running with your own Elasticstack, so that you can just experiment, have a quick hands-on in it, and try to go for certification if you want to go for it. So I'll start with a basic diagram of how the technology's changed with the within just the last 5 years. If you see, moving from different monolith to different microservice architecture, how the paradigm shift was happened. This is just a typical example, as you who has worked in the industry for quite a long time might have quickly seen that earlier there was a single monolith application in which all the database interaction, the front end and the back end logic was coupled together, and this was given as a single piece software. Now there were a lot of advantages and disadvantages for each of the service, and the modern era picked up upon microservices. By microservice, it was mean like a single microservice is doing only one thing at a time or doing one thing at its best, and then interacting with different microservices, and which actually gives us the freedom to develop each of the microservice independent of the different of each other, and also to carry out releases without any dependency. So that's one of the quick benefits that microservices give us. And with the increasing time, one of the things that we quickly came up was Docker. Docker was actually one of the game changers in which you can actually ship your microservices as a single unit without any dependency on the platform. So you can build a container, and any container runtime platform that supports it will be able to support it. And and the issue of that it works on my machine and doesn't work on the another machine has been quickly been a thing of past. With the Docker and the container encapsulation, that has been a real advantage. So one of the things that we have got with containerization is we can with containerization and DevOps and the modern philosophies, is that we are quickly able to ship to the customers faster. We are able to build fast. We are able to do continuous integrations from the day one. Every developer has the freedom to build something, test it, quickly change it, and then if there's some issues, get the feedback, work upon it. And with the various tools like of Jenkins, yeah, continuous integration, this philosophy has been more and more like uh, matured, and it's been like a modern ways of working. So but one of the things that is important but is always not looked at a very good importance is monitoring and observability. Why I'm saying is not looked at as a monitoring observability, because as you see that once you go to production, you already have some dashboards and alerts, and you do monitoring. But we should always ask, is that the kind of monitoring that we are looking for? So why it is completely changing? So as I mentioned again, the whole of the platform has evolved. So from containers, Kubernetes, and microservices, followed by immutable infrastructure and service mesh. You can see there are a lot of technologies and a lot of fancy words that have actually changed the whole architecture of moving towards a traditional server base, where you have a dedicated server for running one application, and where you used to worship it, kind of like that it works properly. And now we are treating as architecture as like it's ephemeral, it can come and go. The only thing that should be running is your application. And moreover, this paradigm shift is not related to only a few startups or a few companies. Almost all of the organizations, from financial organization to health and to various e-commerce, all of these organizations have embraced this change and are actually working on this. So as these systems are becoming more and more distributed, there's a lot more emphasis. How do we monitor it? So why do we actually monitor it? We monitor it to get the better understanding. So once you are running your application in your production, you want to understand that what are the issues, like where is the application failing, why at a certain period of time did the application go down. And also other challenges like when to scale your application up, when to deploy multiple replicas. So that's the kind of understanding that we want from the system, from our application. And for that better understanding, we want to have a better system. For example, better system, I say a better cloud. So once you are deploying your services to any cloud like AWS or Google, or be it on a Kubernetes platform, you start with a one container or multiple containers. Then you see how you should give, how many resources do you need to allocate to it, or how does it interact with different services. Do you need a service mesh with it so that you can better visualize your applications? How do the applications depend on certain third party application? And for all this information, you need a better instrumentation. So better instrumentation is again having better logs, having metrics that expose your application, like how many hits are there coming to it, or what's the peak time of your application, as that at what particular period of time does the CPU is the maximum range, and when is the time that when the CPU utilization is low and you can downscale your application. And again, as this better instrumentation will give you better visibility, and then having this better visibility gives you a better understanding. So that, as you can see, this is a cycle that goes on. Like you improve one step and you move to the second, and then when you move to the second, you again come up to the same cycle after some improvements. So that's actually one of the needs of modern observability is, yes, my application is developed and it is working, but how can I improve it, or how can I make it more scalable or more maintainable? So what's the difference between monitoring and observability? So as as I mentioned, is now monitoring is nothing new. All these concepts are not like containers came and was introduced yesterday. It's not like that. It was way back. People all have already understood the importance of monitoring. But where it different was, like in monitoring, it was like you do a regular surveillance of your application over a period of time. When I say a regular surveillance, you deployed your application and you know that if a person who gives comes with an invalid session ID will definitely get a application error. Or if somebody does a if there's a code issue and there's no data available, there would be definitely be a null pointer exceptions or some kind of code exceptions might be there. So what was that? You were expecting your applications to work in a particular manner, and when you expect your application to work in a particular manner, you also know that how your application will fail. And now your monitoring was more towards how we can actually accumulate those failures, or how do we manage those failures. With Kubernetes, most of the failures that we know have now been resolved. Like your application, if it stops working, the Kubernetes, you can have health checks enabled on it. Your Kubernetes itself kill it and restart the application. So the manual interference with quite is getting more and more less. And your hard failures, like your, for example, like your CPU has run out of memory. Now, in the earlier cases, you have to reboot the system or go into inside the server and check the service. But now all these hard failures are now getting more and more converted into soft failures. By soft failures, I mean that your application will now not be showing an error page, but might be showing a slow degradation. That is, the site speed will be slow, but the application would be still be running. So all this thing is good, but again, at a very high level, we are seeing that the systems are getting more and more complex. The microservices, which are earlier used to be a single place where everything was sitting, now is in a distributed manner. Now your services depend upon other services on various other factors like networking, connectivity, or some other IP changes, whatever you say. And so the application lifecycle is getting more and more harder, and for managing this, monitoring is becoming more and more important. And not and we should and monitoring every aspect, like monitor every DNS change or IP change, is not the way moving forward, as it will get a lot more cumbersome with the new integrations and as your service evolves. So what we should be looking is for more looking for observability. So we should by observability is a very at a very simple step is understanding your how system behaves. By understanding your system behaves is just not like not looking at your logs completely, just not saying that if the logs are saying like everything is fine, your application is fine, but looking at certain other parameters also, like that we'll go forward to. But the few parameters that you can see is the metrics, like how much CPU is your application utilizing, or how many requests to a particular endpoint was done for the particular application at this particular interval of time, or how many nodes or your application is currently running. So these are the kind of different metrics information we can have. And so these metrics information will provide us a good visibility to the different failure modes that can happen. So one of the failure modes that you can see is that you have an orchestrator in Kubernetes, like Kubernetes running, and your CPU, your pod memory or your container memory just ran out. Now your orchestrator will automatically restart the pod. So without your any information that why it got restarted, you'll always be thinking that what caused the pod to restart, or what caused the orchestrator to do it. But with observability, you get the information that why it happened, why the limits were breached, what were the transactions that were taking a lot of time. So that is kind of the observability that will try to aim when we work on that. So coming to how and why of the monitoring, I've distributed the data that like a typical application into four quadrants. Like once we deploy an application, we know certain knowns that we know that we are aware of. For example, a system has 1 GB of memory, then we know that if you go for more than that memory, your system will definitely go fail. But there are certain unknowns, that things that we are aware but we don't understand. For example, the system exceeded its memory, but why it exceeded, what was the thing that it caused the memory exception. Moreover, there would be a lot of unknowns, like Kubernetes being an orchestrator. We know how Kubernetes works, but we don't know the inner working of a Kubernetes. Like how does it actually destroy the pod or recreate the pod? How does the scheduler actually work? So these are the kind of different unknowns, but we know that a orchestrator will handle it. And then there are completely unknowns. So why completely unknowns is like your orchestrator is automatically uh, causing a process to restart and your process is not running up. So these are the different kinds of unknowns that we'll be having. So what actually we give is, so observability is more towards the discoveries and the exploration that we do from the system that we are in, and monitoring is more towards the hypothesis and the testing and the facts that we know that the application has. So moving forward, so there are the three pillars of observability. When I, as I mentioned, that logs is one of the fundamental thing that any application and every application developer looks to see that their application is running fine. But the other two pillars that might not be aware of is the metrics is like how your system works, like the number of requests, the CPU count, and then there's the traces is kind of sampling or kind of tracing how a request flows in your application. Like if you are running a Java application, from the request mapping, how does it go inside to the database transactions, and similarly how your Node.js application works to each of the requests. So these are the different three pillars of observability we should be talking about. Each of these pillars has its pros and its cons, but depending upon like what's required, what's important, all of these three things should be considered when analyzing or when observing a system. So before we jump into the Elastic Stack, I will like to quickly give you a quick landscape mode, a quick overview of what's the CNCF landscape of observability. So as you can see here, this is an official picture of observability and observability tools that the CNCF actually is supporting and is in their catalog. So there's no one. At the end of the day, there's no one tool that will fit your picture or will fit all the cases. So you can see there's Prometheus for monitoring, then there's logging, then there's tracing. So but how you want to pick up a tool and want to leverage this depends totally upon your use case. So based upon that, we'll be discussing today about Elastic Stack, like how Elastic Stack actually enables the observability of a particular application. And so continuing it, so Elastic Stack or ELK stack is completely is just a short form for Elasticsearch, Logstash, and Kibana. And Elastic Stack is by introduction of Beats. So we'll go through each of them one by one. So as a very high level of Elasticsearch is basically a search engine, which actually gives you capabilities to do a full text search, and is not and just not search. It also gives you capabilities to do analytics and do a geospatial queries. Also, this is the benefit of Elasticsearch is it's a near real time search engine. So by a near real time search engine, it's like as soon as the document is indexed by Elasticsearch, it will be searchable. So the other things, the benefits of Elasticsearch is distributed, scalable, highly available, and resilient system. By distributed, that means that Elasticsearch is just like Kubernetes, can run on multiple nodes, and all of these nodes will actually serve your requests. And as if you need more capacity, you can dynamically scale the nodes, add new nodes, and if you want to remove the nodes, you can directly remove it. And also we'll see how it is highly available and resilient system moving in the next slides. And other benefit of Elasticsearch is it's the interface is HTTP and JSON. So most of the application different language clients like Java, .NET, Node.js can directly communicate with Elasticsearch over HTTP, and mode of communication is JSON, so which is quite easy to understand and easy to pass. So most of the libraries in different languages are supported. And also Elasticsearch is the main thing, is kind of heart of Elastic Stack, where all the heavy lifting and everything is done. So how, at a very simple level, if you want to compare Elasticsearch with relational databases, you can, this is a kind of different similar terminology that you can keep in your mind. Like in relational databases you have a database, so similarly we have in Elasticsearch we have a thing called index. And relationship databases we have a thing called table. In Elasticsearch we have a type. And similar in relational database, we have row, document, column, fields, schema, and mapping. So one of the things that you can see is it's a documented oriented database. So by I mean a document oriented database is like every message that you want to save into Elasticsearch is saved in form of a document, and that document is then saved inside Elasticsearch is in form of JSON. And for fast searches, each of these documents is then saved as inverted index. So inverted index is kind of internal working of how Elasticsearch does store the documents, does store the fields, and how it's able to give you search results in a very short period of time. So how Elasticsearch actually a distributed system. So typically if you have an index of say, index as I mentioned is kind of a database, so every information that you put is actually saved in an index. So if your index assume is like of 1 TB in size, so how Elasticsearch will actually distribute these indexes, each of the index will be divided into different shards. Each of the shard, you can take the shard as a local store or a kind of a local small Lucene instance where your searches is performed. And so your index is divided into 256 GBs shards, and then each of these shard is then distributed to your different nodes. So for example, each of the shard in 5 would be distributed to each of the 3 node cluster. And how it would be highly available is like for each of the primary shard that it is saved, Elasticsearch will create a replica shard in a different node. So similarly, if shard 4 is created in node 1, the replica of shard 4 will be created in any different node like node 2 or node 3. So in case of any failure, like for example, if tomorrow node 3 goes down and it, so what will happen is all the replica shards like shard 3 will be promoted to primary shards, and all your and new shards will be created to have the replicas. So but in this 3 node cluster, we can see that if one of the node goes down, we'll still have all of the data, like none of the data would be lost. The only thing that when Elasticsearch would be lost is when we once we lose both of the once we lose both of the nodes. In that case, we'll only end up with one shard instances here, but it will not be highly available. And how it is fast is because, so once you do a query to Elasticsearch for any term or any text, what it happens it the Elasticsearch goes to the query goes to one of the nodes, and in that particular node, Elasticsearch then queries all the different shards that would be relying on different nodes, and that particular node will then grab all the data, do appropriate caching of the data of the query that you have done, and will then give you the results. And then if you fire another query based upon the cache that it will have, it will actually give you results more than in a more quick time. So coming to that, then the next part of Elasticsearch is the Logstash. So Logstash, you can treat it as a ETL pipeline. So Logstash can digest your logs from different sources. You can say it can read logs from a particular file or from different cloud vendor, and then can pass it to a different monitoring solution. It can be Elasticsearch, it can be S3, it can be Kafka, or it can be some other source, or also it can be any stream that you want to give. So what Logstash can do, it can read the log, do some transformations on it, that is extract some useful information out of it, and do some processing, and then push it to some other output, and that output can be anything, depends upon the use case. And the final thing, not the final thing, but the second last thing is Kibana. Kibana you can treat is as a window to Elasticsearch. Nobody, like, though Elasticsearch gives you a REST API, but it would be very difficult to do write queries every time, or to gather data quickly. So Kibana is kind of a visualization tool which actually does all the heavy lifting of querying and all the stuff, queries Elasticsearch for you, and you can use this to create good amount of dashboards and do a lot of analytics, and also you can create your alerts, etc. on it. And also it gives you a very good UI, so that you can actually do all the things like read your logs, manage how your application is working. And also there are several other capabilities, like, though it will not be covered here in this slide, but like for SIAM, that is a security capabilities are also pre-baked into Kibana, so you can use Kibana to leverage SIAM capabilities. So the last component is the beats. So beats is, you can are treated as shippers. So your application might be running in some other cluster, and your Elasticsearch might be in a totally different cluster or might be running on a VM. So how does your logs get shipped to the Elasticsearch? So that kind of activity is done by beats. So there are a lot of beats, as you can see here. There's file beat, which actually reads all the file logs. Then there's the packet beat, which actually reads your packet data, that is network data, and sends to it. And also then there is heartbeat. The heartbeat is kind of a uptime. So there are a lot of beats, and also a lot of community beats that you can actually use to extend Elasticsearch. So that's these all so all these beats are the kind of log shippers. So getting started with Elasticsearch. So before we jump directly into the demo, I would like to quickly to give you the different ways of how you can start the Elasticsearch. And if you can then, as soon as the webinar finishes, you can spin up your cluster and start working on it. One of the easiest ways that you can start Elastic Cloud is directly signing up to the Elastic Cloud portal. So Elastic Cloud Portal is a Elastic's own Elasticsearch as a service platform. So where you can sign up for a 14-day trial period without any credit card, and can you quickly spin up your Elasticsearch cluster. So as you can see here, I've quickly spinned up a Elasticsearch cluster. One of the best things that you can do here is experiment. There is no cost involved here, so you can spin up a cluster, and as soon as the trial expires, you can like start working on a new cluster, or you go for a new trial license. So that's the kind of, and moreover the node configurations that they give is quite high, so you can, based upon your need, you can actually spin up your Elasticsearch into different cloud vendors. So might be because I have already have a cluster, but in a trial license you can select any of the cloud vendor like GCP, Azure, and AWS, and spin up your Elasticsearch cluster. The other ways that you can do if you want to work locally is you can use Docker Compose. So I've mentioned the link here, so you can go through it. So this is Elastic on using Docker Compose. So you can use Docker Compose to quickly spin up Elasticsearch, and in this repo you can use this repo file to quickly leverage the Docker Compose definition. And this repository is quite updated, and it's used quite, as seen by the number of stars. So if you want to start in your local, how like experiment with Docker with Elasticsearch, this is the way that you can go to. And also for the persons who want to go directly into the VMs, like I want to do everything from the scratch, like I want to install Elasticsearch binary and want to do all the things like system configuration, want to have certain my specific configuration, they can definitely go for Vagrant. So those of you who are not aware of Vagrant is a kind of a virtual box uh, orchestrator. So you can use a like so CentOS VirtualBox kind of VM image spin up in your on your system, and it's like a kind of a virtual machine that you'll be getting, and then using that virtual machine you can spin up the Elasticsearch. So this is one of the repositories where you can use to create your Elasticsearch from the scratch. You can spin up a Vagrant file, install all your Elasticsearch binaries on it, and at the end of the day, when you do a Vagrant up, you will have your Elasticsearch cluster. And for those who are actually want a quick Kubernetes solution and have a Kubernetes cluster ready, and they can actually experiment on it, for those guys, the Cloud on K8s is one of the good starting point. So Elasticsearch has their own Elasticsearch Kubernetes operator, which you can actually use to deploy in your Kubernetes cluster. And within just a few minutes, you will have your end-to-end Kubernetes TLS enabled cluster. So just following this guide definitions here, you can have your Kubernetes cluster just in a jiffy. So yeah, so this is the different ways how you can spin up your cluster, and for learning purposes, and for if you want to have for a demo purposes also, you can go towards these any of these tools. So moving forward, let's have a quick demo. There's a lot of theory now. Let's quickly jump to the demo part. So what I have, as I mentioned to you, I have created a new, I've used the Elastic Cloud service to create an Elastic Stack. So there are a lot of architectures in Elasticsearch. So what I have gone through is I've gone to a very simple two data node, two master node, two data node and one Kibana uh, configuration. This is a kind of very basic configuration that you go for a highly available Elasticsearch. So once you have signed up from Elasticsearch, what you will see, you will get a Elasticsearch, a kind of, you'll get a Kibana portal. So those of you who is seeing this Kibana portal for the first time, this is the window that I was saying, when I was saying that you can use Elasticsearch either through the endpoint, or you can use a UI portal. This is the UI portal that you can use. So if I show it to you, this is this is Kibana. It's like you can treat as like all-purpose tool. You can fire all your request APIs from the Kibana, and also you can do all the different kind of discovery-based tools like analyze your logs, or as soon as it loads up. Yeah, so you can analyze your logs here. All your applications would be running up, and if you have configured them correctly, all the logs would be then coming up into the respective indexes. And also the other things that you can have here is the observability part. We'll talk more about this when I'll show you how the demo app is created. So moreover, the other benefits of Kibana is like you can do dashboarding, you can have maps and machine learning inside it. And also one of the best things that you can do, you can use Kibana is to do visualizations. By visualizations, I mean like most of the times if you are working on any UI tool, one of the things is like you get puzzled is how do you want to visualize the data? Like there's a lot of data, but how do you make leverage of that data? So what Kibana actually can do for you is they provide you a very good functionality of a term called lens. So lens is like you select your particular index that you want to visualize, and what Elastic will give you the different fields that it has, and then based upon these fields you can just directly push and put here, and you do a different combination of the code. And based upon that, Elasticsearch will give you a different kind of visualizations that you want. And based upon these visualizations, it's like if you like it, you can directly save it from here, and if you don't like it, you can just experiment with it. So there's no thing of learning complex queries like how these visualizations are made. You can directly do a drag and drop kind of workaround, and you'll have your visualizations created in a very quick amount of time. Also, you can have a lot many dashboards. So when I say dashboards like can be from simpler, like it reads a request, sees what's the average access number of logs that you are getting, and what are the different access codes. So these are all the different kind of dashboards that you can create. So let's now jump into how Elasticsearch actually enables application observability. So for the demo, I have created a minikube cluster. So this minikube cluster is running in one of my cloud environments, and I've deployed a certain applications on it. So the application that I have deployed is Spring Boot Pet Clinic. It's a kind of a sample Spring based application like that the Spring team has created, and it's available on Docker Hub, so you can directly use it and try to just run it like without any requirements. They support a Docker image for it. Just spin up a Kubernetes cluster and just deploy this image, and you'll be good to go. And the other things that I have is an Nginx. So all the requests that are coming through Pet Clinic to this application are coming from Nginx. So Nginx is treated as the load balancer above the Pet Clinic. So every request goes to Nginx, then goes to here. And then there I have created a MySQL deployment. So this Pet Clinic save all the database queries in this MySQL. And then there's a separate port called Thea that I have deployed. Thea is nothing but just if you have deployed your application, you can have a remote Visual Code, Visual Studio kind of application. So you can work it in a remote way. So how does this application work? So there's a application portal in which you can do find owners, or you can create your owner. So when I do a find owner, it searches for you. So sorry. So what it does a finding on it. So as soon as you search, it goes for it and gives you back the data, and based upon the data that you have entered, it gives you the information back. So a typical model view controller that you go through a application, you do a search query, it gives you a result out of it. But that's the what we can see. But how do we do it from a monitoring aspect? How do we visualize or see that our application is doing as like what we expect to do? So in Elasticsearch, Kibana, there's a have a separate section now in 7.8 called observability. So in observability, it gives you a different kind of metric information like logs, metrics, and APM. So we'll look into each of them one by one. So when I say metrics, so as I said that I have deployed a single node Kubernetes cluster in Minikube. So how I can actually see that the application is working good. So I can see that I by deploying one of the beats called metric beat. So metric beat, I can see that my current CPU usage for this particular VM is 10.1%. Sorry, my current memory usage for this particular machine is 10.1%. And also, if I want to do a Kubernetes pods, I can see that the different pods running on my system, only these pods are using this much amount of CPU and this much amount of memory. So, and if I want to see memory usage, I can directly compare. So this is the amount of memory usage you can see. So as you can see, this is it gives you a single point of view where you can see all the different memories that is used by each of the pod. So what you can do more from it. So if you say that I've selected a pod, I can quickly create a alert from here where I can say that if my memory usage is above certain percent, like if I want say 5.9, I say if it is above 10%, then quickly give a error that the pod's utilization is up. And also from here I can see if the pod is running high, I can directly click here and but it will but Elastic will do, it will try to open the logs from here. So in case where you don't have the access to the server or go to the Kubernetes cluster to get the logs, you can come here and you can directly see the logs from here. So just giving the Kubernetes pod ID here, you can see that these are the logs here, and based upon certain highlights, like I can say error, if there's a term called error, what it will do, it will highlight it here, and based upon that I can just quickly scroll through the timeline and see that what was the error. So for example, here I can see that I got an SSL exception error during this particular amount of time, and now following this particular stack trace, we can see that what caused it error. So there was some disconnecting error that it faced. So this is the kind of relation that you can do, like based upon your CPU memory, if it was going too high, you can directly jump to the pod metrics and see at what particular amount of time, at what particular instance of time was it high, and what were the logs that application was providing. And also by metrics, by having APM capability, that is application performance, we can see that what are the different areas or what are the different transactions that are taking a lot of time. So in our case, as we were doing a lot of find requests, find by owner, so we can see that by deploying a APM agent, we see that the queries that were fired from here, and most of the time that was taken in order process find form was most of this was done from select query. So if you have a kind of if you want to optimize it, and you can introduce a Redis based cache here, which actually stores all the owners or gives you select operations results quite fast, you will see that that you can quickly reduce the time quite low. So that's the kind of different visual like APM metrics that you can get. Moreover, using this again, as I mentioned, you can have a lot of dashboards. Like for the Nginx that I have deployed, I can have a fancy dashboard here. Most of these dashboards are can be provided out of box, and also you can extend these dashboards as per your need. It's not like you cannot change it. Even though this is an original dashboard that was provided by Elastic as part of setup, I can quickly change and edit each of the components. I can add new in visualizations or change any visualization that I want from here. And also I can restrict it to who can see this, who can see what. So that kind of stuff can also be done here. And also, as I mentioned, like you can do from your logs metrics. So again, the emphasis upon these metrics is like, because most of the times when once we are debugging any problem issue, what we do is we just directly jump into the logs. We just see whether what there any issues or errors that were reported by the logs itself. But we tend to forget the state of the system. We tend to forget whether a node at that particular time was actually working, but was there any other issue other than that, other than just the application code that was happening. So these are the different kind of areas that will actually give the system more observability, more exploration, different kind of stuff that you can see. So yeah, so that's one of the things that you can use for Elasticsearch. So you can create your own visualizations and have your different APM and observability metrics. So yeah, so that would be like a high level view of observability that Elastic provides to you. And one of the benefits that Elasticsearch will give you is you can use Elasticsearch as a centralized logging solution for all your different clusters. So for example, you can have your clusters running in different accounts, like in some can be in Azure, some can be in your on-prem, but you can have your Elasticsearch as a centralized logging place where all of these logs are getting dumped, and based upon these logs you are able to see like you can able to visualize, create some alerts, and make your system more observe or more maintain your system in a more better way. Yeah, so that would be all from my side. I hope that would be I like I've given a good overview. So I'm good to take any questions. Yeah, yeah. Yeah, so one of the things that Elasticsearch gives you is gives you a trial license. So Elasticsearch also has its own open source version. So in but the thing with the open source version is they don't give you a lot many tools uh, like I mentioned this observability. So all this stuff like CM, SIAM, and metrics. These are some of the features in these are paid, and some of them are free. So what you can do is you can go for a trial license or go for an open source license. See all of your needs are there. If it is not, then you can sign up for a trial license. Mhm. So yeah, so just to add on that, so XPack earlier was a enterprise feature, but Elastic had some issues with one of their cloud providers, and due to that, they have changed their licensing. And now what they are doing is XPack features like your username, password, and your authentication are now bundled as free, but certain other parameters like machine learning, your alerting, are like for like alerting are still a paid tool, and are still you have to pay for that, have a license for that. So if you see here, if you have a paid version of Elasticsearch, you can do a lot many things, like you can manage your log stash pipelines from the Elasticsearch itself. So you don't need to have log stash pipelines managed at the log stash level. What you can do is you can deploy log stash, and then you can manage all the log stash pipelines from this here. So you can create a pipeline from here and then deploy any change dynamically. So your Logstash will automatically read the configuration from here and will do all the changes. So you can say each of these things is like you don't need to go into the Logstash to do it. Everything is handled in Elastic. And also there's a beat management. So what you can do is you can enroll your beats and into the Elasticsearch, and then you can dynamically change your beat configuration on the fly, like which are the paths that you want to take, or how do you want to, which of the data do you want right now. You can enable debug information, or you can do enable auto discovery. So that kind of different features can be enabled from here. So these users and roles are now part of open source, but again few of the features like roles and API keys are still a part of their enterprise suite. So if you want to have what comes and what doesn't come up, I'll recommend you go to Elasticsearch documentation and just select on the feature, and based upon that feature you'll be able to see whether that's an enterprise feature or is it a open source feature. But again, you can go for a trial license. They are very generic with their trial purposes. Even if you have your trial expired, you can shoot them a mail saying your use case, and they'll definitely give you a trial license. So I've also have requested a trial license myself a lot of times. So they actually give you a 2 months license, just as much as you can, as much as you have a valid case. Any other guys? Okay. Yeah. So if there are no more questions, like you can directly come connect with me on my email, or just like ping me on Google. Like just drop me a mail. I'll be happy to respond to it. Or you can just drop a message on the WhatsApp channel. I'll be there only. So yeah. And if for any other queries or any questions, I'll be happy to help.
Yeah, if you can share the WhatsApp channel link on the chat, that will be helpful.
Yeah. So Shash, can you share that one?
Yeah, sure.
Yeah. Sure. Cool.
Oh, okay. Thank you, Gaurav. Thank you. That was very
Yeah. No worries.
elaborative information about it. And I hope everybody who has joined us got to know if that was new things, then they have probably a very good understanding of ELK stack and everything. So we are still open for questions if there is any.
No worries. So if there are no questions, it's good. So as one less take more time for me. Yeah.
Okay, if there is no more questions, so we'll call it a day.
Yeah.
Thank you very much. Thank you, Gaurav, and everyone.
Yeah. Thank you
And
everyone for joining.
very, thank you. Thanks, everyone.
Thank you. Bye bye.
Bye.
Bye.